Here are the answers to, I'm going to try to position it so you can pause it. This would be a good time to pause. I think all of the answers are there. Now, if you got all of them, or mostly all of them, or if you missed one but understand why you missed it, and you're not interested in the optional challenge problem, you can move on to the next slide in Nearpod. But I'll go over these now. This was an arithmetic sequence because each term was increasing by 5, so the common difference was positive 5. Sequence n was a geometric sequence because we were multiplying by 5. If you take any term and divide it by the preceding term, you get a common ratio of 5. 50 divided by 10 is 5. 250 divided by 50 is 5. Sequence O was geometric, but in this case the common ratio is 1/2, not 2, because I'm not multiplying by 2, I'm multiplying by 1/2 to get from 16 to 8, or from 8 to 4. Or you could take a term like 4 and divide it by the preceding term 8, and you would realize that, okay, 4 divided by 8 is just 1/2. It's a geometric sequence with a common ratio of 1/2. Sequence P was on the video. I extremely hope everyone's still using those videos, especially in this situation. So you know, if you use the video, it's an arithmetic sequence with a common difference of -3/8, so I'm not going to go over that twice, it's on the video. Here it's times 5, then times 6, then times 7. So there's not a common ratio, and it's definitely not arithmetic, so this one is neither. Sequence Q is neither. For sequence R, it's increasing by 2 each time. So the rule would start out with 2n, but then when you try, if you just have 2n, here's the other thing you need to realize. N is 1 for that first number in the sequence, 2 for the second number, 3 for the third number, etc. So when n is 1, 2n would just be 2, but I need 7, so I need 5 more than that, and that's where the plus 5 comes from. And then you test it with another value of n, like 3. If you double 3, you get 6. If you add 5 to 6, you get 11. So it matches the this equation is confirmed by the sequence. And then to find the 18th term, you substitute 18 for n, and you get 41. Sequence S was also on the video. The equation is, oops, I don't want to show that yet. The rule is 11n t equals 11n minus 5, and the 12th term would be 127. Now if you tried this optional challenge problem, I don't know, maybe you figured it out and got excited and shared. I'm doing this about a week before you're going to do this, but maybe you shared a solution on the discussion board or something. That would be cool. But in order to understand how this sequence works, you have to realize that each line describes the line above it. So here's what I mean by that. When you're on this line, it's describing what's up here. What's up here? There's a 4 up here. How many 4s? There's 1 4. 1 4. There's 1 4 right there. Now, what do we have on this line? Well, I have a 4, but I also have a 1. So I have 1 1 and 1 4. 1 1 and 1 4. It's just the line describes the line above it. Here I have 3 1s and 1 4. 3 1s and 1 4. And then finally there's 2 1s, 2 1s, 1 3, 1 3, and 1 4, 1 4. And so the next line would be, oh, how many 1s? 3 1s. How many 2s? 1 2. How many 3s? 1 3. And how many 4s? 1 4. 3 1s, 1 2, 1 3, and 1 4. 3 1s, 1 2, 1 3, and 1 4. And you can just keep going like that. You see some interesting patterns if you keep going. But it's a different kind of sequence, but kind of a fun problem. Oh, I said I would tell you the story. So a second grade teacher at my last school assigned this problem to her students, and her students didn't understand how to do it. And so the parents tried to help, and the parents got frustrated because they couldn't solve it, and then they emailed the teacher. But this teacher assigned this problem without having tried it herself. And so she was in a jam because she couldn't figure it out either. And so she emailed all the math teachers at the school. and I spent all day trying to figure out the sequence, and I could not figure out how it worked. Then I created a post on a discussion board describing it and got an answer within minutes. So that's the power of the internet. You can solve, well, I guess I feel weird saying any problem at this time. You can solve most problems or answer most questions just by reaching out to other people who have similar interests. Find a good math forum, and people are there just eager to answer challenging questions. So that was kind of an interesting story related to that sequence.